Okay, the question we're looking at today says write down the complex conjugates of the following complex numbers. Another thing that we have to understand, let's just recall something. So any complex number can be written in the form a plus bi, right? In this case, a we say is the real part, and then bi is the imaginary part, okay? Now, if I'm looking for a conjugate of this complex number, A will stay the same, but what will happen is we are going to change the imaginary part, and it will only change the sign. It will be negative bi. Let's look at number 1. So for number 1, the imaginary part is plus 7i. So if I want its conjugate, that means it will be 2, now minus 7i. If I look at number 2, the imaginary part is negative 4i, so therefore its conjugate will look something like this. It will be 8 minus or plus 4i. It will be 8 plus 4i. Number 3, we're looking at its imaginary part is 5i, so that means its conjugate will be equal to negative 5i plus 6, which you can write it as 6 minus 5i if we want to get it in that form a plus b. Number 4, if I look at its imaginary part is 2i, so therefore its conjugate now will be negative 2i minus 9, which is equal to negative 9 minus 2i. Number 5, its imaginary part is negative I, so its conjugate will be 3 plus I. So for number 6, we need to write it in this form, a plus bi. So we need to simplify first. 2 times 3i will give you 6i, and then 2 times negative 1 will give you negative 2, right? So you have it in this form. You can even write it as negative 2 plus 6, negative 2 plus 6i. Now, if I'm looking for its conjugate, that means it will be negative 2 minus 6i. Let's look at number 7, just a simple question. Let's say they give you a complex number, and its complex number is, for example, 10, okay? If I want to write it in the form a plus b, that means it will be 10 plus 0i. Now, if I'm looking for the conjugate of this, the answer will just be 10, because if you think about it, I was just going to say 10 minus 0i, which of course is just 10.